Okay, great. So the next question number 4.1. So we got this diagram. They're asking what type of angle relationship is, let me go. So this angle, right? This is the angle AOC. Okay, so the angle AOC. So O is where we got the vertex of the angle. So, and then what the relationship between this angle and, let me just change, and this one. So what's the type of relationship between this blue angle and the red one? Well, so the relationship, we know that angle AOC and an angle BOD. What's the relationship here? These two, they are what? They are just vertically opposite angle. Vertically opposite angle, right? So remember, vertically opposite doesn't mean it must just, of course, it must, the name comes from the fact that this angle here and the one at the bottom, the top and the bottom here, they are vertically opposite, right? But remember, if you rotate this drawing, this will become at the top, this will become at the bottom. So that's why we also call them vertically opposite. So let me just do this. When you have a line, suppose you have a line right here, and then let's say you cut it somewhere. Let's cut it here. So whenever you go two lines, it cuts the point in two. It cuts the space in four. If this point, let's say, is point A, so we can divide this space using the number. So you got space 1, 2, 3, 4. So all of a sudden we've got 4 angles. And in this case, so angle A1, which is this one, will be equal to angle A3. This one here. Why? Because the reason is they are vertically opposite angles, right? Likewise, these two, angle A4 would be equal to angle A2 for the same reason, vertically opposite angles, right? These two also are vertically opposite, although it looks like they are horizontal. So we don't want to say they are horizontally opposite angles. You understand what I mean? So we'll just keep the same reason, because if we also rotate the drawing, so A4 would be on top, A2 would be at the bottom. Okay, great. So let's move to the next one, 4.2. So the next one. So we got the figure. And what if we go there? So here, just a quick reminder. You know when you have a straight line like this and you just cut with any other line, so it forms a point here, right? We have 3 space. Let's say we have A here. We have 3 space. Suppose if you measure here. Let's say this is 40 degrees. So what space have we got here? We got, let's say, 1, 2, 3. So we can find all these angles, right? So we got, what will be A1? Angle A1. A1 will be, so we understand that 40 degree and A1, they are on the straight line, right? So let me just delete this. So 40 degree is from here up to there. And then this angle here, this A1 is right there to there. When you sum them, these two, it makes this straight line, right? So 40 degree plus A1, it gives you a straight line. Straight line, remember, is always 180 degree. This is very important. It's a very important concept to remember. Okay, so I'm sure it's gonna come back again. And on the other side, this is when you have the straight line. Whenever you see a straight line at a point in the section, you must know that you have 180 degree. You know, some angles are summing up to make 180 degree. Likewise, when you've got lines that are meeting, intersecting like this, and whenever you see like a box, it means you have 90 degree there. And if you cut it with another angle, it means those two angles are summing up to get 90 degree. So let's say if you have 20 degree here, this is, let's say, point A. So this is 1, 2. So angle A1 plus A2 is 90 degree. For the mere fact that they are summing, there's a box here, it means it's 90 degree. It's a right angle, right? That's what it means. Let's go to 4.2. 4.2 here, it means we have a right angle here. It means we simply have 90 degree. If we have 90 degree there, because 90 degree also, we have a straight line. Remember what I said about straight line here. When you have a straight line, it means all the angles right here, they add up to make 180 degree. To make this straight line. Right? So what does it mean? It means 90 degree plus this one here. So I'm done with this one. This one is 2x plus this one is given already 20 degree, gives all of them, they add up to make this straight line, which is 180 degree. And now it's easy for us to solve for this. But what are we asked here? They say in the figure below, ABC is a straight line. So we know we have 180 degree here. This is 90 degree, this is 20 and 2x. Determine the value of x. So what we got to do is just to solve for x here. What are we going to get? Well, it's going to get, we can put x on one side, the x's. We have 2x. We'll have 180. This term goes that side, becomes negative. This term goes that side, becomes negative as well. Right? So we'll have 2x equals 70 degree. I'm sure, and x will be 35 degree. So we managed to solve for x. Great. Now let's move to the next exercise. They say calculate with reasons the values. Okay, now here already this situation is calling for what I've explained before here. Right? Right here. I've explained about vertically opposite angles. Okay, right. So we can come back here. What do we see here? We need to find, I'm sure, x and y. So what do we see here? We can see that already this angle here, difficult to draw. This angle is equal to which angle? Is equal to this one, right? So I can see that x is equal to 25 degree. What's the reason? Well, vertically opposite angles. Right? Now, what about y? So let me just change colors. So y is basically this angle. Y is vertically opposite to angle AOF. But AOF is not known. We don't know this angle. Can we find AOF? Yes, we can find AOF. How can we find AOF? Well, we know we have a straight line here. Okay. This is a straight line. Let me just delete it. I didn't draw it properly. So from C to D, we have a straight line. And how many angles have we got on that straight line? We've got 3 angles. We've got the first one, 85. We've got the second one, which we don't know. And then we've got the last one, which is 25. All these 3 are on this straight line, CP, right? So how do we express it in mathematics? Well, we can rewrite it. We can just say 85 degree plus the angle we don't know here. We can call it the unknown. We know that angle is the same with y because they are vertically opposite. Can we say that? Okay. We can say it's y plus 25 degrees equals 180 degree. So the reason we say angles on straight line. Right? So the angles on the straight line. So all these angles, they sum up to make the straight line. Therefore, we can solve now for y. So what are we going to have? Y equals 180 minus 85 minus 25 degree. So what have we got here? This makes 90, 110. So y will be 70, right? Y equals 70. Yeah, I'm sure that's the answer. So we found y to be, so we found this value here. Okay, normally here we're supposed to not write y, we're supposed to write the angle itself, which is O. So that's the name of the vertex. So it's A and F, right? We're supposed to solve for that. So here we're supposed to find angle O, A, and then F here. So AOF. So this is the answer for that. AOF. So we found 70, and therefore we are going to say now angle Y equals this OAF equals 70 degree, because also we've got vertically opposite angles. Because we managed to find this angle here. Now we'll now say that the top one, Y, equals this angle AOF because of this reason, vertically opposite angles. But it doesn't matter. Even if you plugged Y here, we will understand why, because initially you decide that this angle should be equal to this one at the bottom. Therefore, you also substitute by the same value. Still, it's still the right logic. Okay, great. Let's move to the next one. Okay. Question 4.3.2. Okay, so here we've got some angles to find. What are we given? We can see that so this line, QU, is parallel to RV. How do we know? It's because of this double arrow here. So there's this double arrow. This double arrow means that these two are parallel. And then this single arrow, let me check the line with single arrow, is this one. It also means that these two angles are parallel. Okay. And what is the sign of parallel? Is this one. That's what it means to be parallel. Okay, two lines are parallel when they don't meet, right? So basically, and a quick review. Whenever you've got two lines that are parallel, let's a quick reminder. I know some of you have forgotten. Suppose I have a line parallel here. I have another line parallel here. I have another line parallel here. Okay, I'm going to cut them by this line. If I cut them here, I can cut them here, or I can cut them like this, right? So can you see the angle there and the angle there? They are equal. We call them corresponding angles, right? And here, the angle there and the angle right there, they are also equal. We call them alternating angles. And now here, the angle inside here and the angle right there inside, which makes like a U. You know, so we can see we've got sort of like a U here. Here we've got some sort of a N. Here we got some sort of a F. So here, right here, these are called co-interior angles. Co-interior angles are not equal, but they sum up to make 180 degree. These two sum up to make 180 degree. These corresponding angles are equal, and alternating angles are also equal. This is very important. So whenever you see this kind of shape of F, you know, or when there is like N, because remember the key here is this is parallel to this. These two are also parallel. And let me just put 3 here. This is parallel to this, right? Whenever you see two lines parallel like this, it's calling for one of those situations, either corresponding, either alternating angles, either co-interior angles. So now let's come back to our exercise here. So there it is. So we can see we've got our drawing here. You can see you've got two sets of lines that are parallel. That means we'll have either of these situations. Now, let's begin. Where can we already see something, a pattern? If this is 15 degree, right? We've got 15 degree there. Where else do we have 15 degree? It means, where do I see a F? Can I see a F? Let me use another color. Can I use? Probably a green color. Can we see a F here? Can we see a F here? So whatever is inside there, the F. So can you see that 15? If I have 15 here, P1 should also be 15. So P1 equals 15 degree. Let me just remove it to make the drawing clean. Otherwise, okay. So P1. So angle P1 is 15 degree. Because, and what is the reason? Is corresponding angles, right? Because whenever you can draw the F, that means you have corresponding angles. Let me just reduce the thickness of this. Yeah. Great. Now, what else do we see the pattern here? Where else do you see angles that, lines that are parallel? This one here. This line is parallel to this. So we can also extract something there. So this line are parallel to this. What can we see here? We can see that this angle Q1, right? Q1 and P2 plus P1. So all this Q1 and P2 plus P1 are co-interior, right? So let me just remove it again. So remember P1, let me just write, we said this is 15 degree, right? If this is 15 degree, now what is Q1? We've got 15 degree here, right? Now we know that there's a relationship between Q1 and all this, right? And the relationship between those two is the same case here. They are co-interior angles. Because it makes a U. Can we all see that there's a U here? There's a U. Remember, this makes like a U. And here we've got a U like this. We got a U, right? Let me just remove it so that it doesn't get dirty. So this angle here, Q1, and this one, P2 plus P1, are related because they are co-interior angles. Okay, so great, that's wonderful. Now, it means I can join P1. So P1 plus P2, these two angles, is basically 15 degree plus 90 degree. How do I know I've got 90 degree here? Well, because I've got a little square here, okay? That means I've got a right angle, which is 90 degree. So the total here is 115 degree, right? No, 105 degree. So this is 105 degree. That means all this angle here is 105 degree. So it means Q1 is equal to Q1 plus 105 degree is equal to 180 degree. The reasons is co-interior angles. Remember, co-interior angles, they sum up to give 180 degree. Remember, these angles and this one, their sum gives 180 degree, right? Now we can solve for this, for Q1. It means Q1 will be equal to 180 degree minus 105 degree. And here we're going to have, this will give us 75 degree. Right, I think that is all. I think we solved for P1 and Q1. So we're done with this exercise. Okay, great. Now let's move to the next one, the next exercise. 4.4. Okay, so 4.4, what have we got? We've got a parallelogram. Okay, guys, we know the properties of parallelogram. Okay, quickly. Parallelogram. What do you know about the parallelogram? So, let's see. Parallelogram basically means that. So, let's say I've got this side, which is parallel to this one, right? So, this is parallel to this. Okay, let me just elongate it. And then the other side here, will also be parallel to this one here. Sorry, it's difficult to draw perfectly. So these opposite sides are basically parallel, right? And as a result, opposite vertex have got equal angle. This angle will be equal to that one. And the other property is that the diagonal bisect. So the smaller diagonal bisect the longer diagonal and vice versa, right? So it means bisect means they cut each other by the middle. So that means the distance here is equal to this distance. This distance is equal to this distance. Very important properties. Okay, so okay, this was just a reminder, no problem. So I can just remove it. So, but we are asked to find sorry, I should have just deleted it. Okay, we asked to solve for y and for x. So we got y here in this case. I've got, this is x, and let me just put my y in green. So this is y. Great. Okay. So I need to break the problem in small. What do I see? Do I see any pattern? Okay, already I've got, so because I know that in a parallelogram, this side is parallel to this side, that means I can now use the same concept here, you know, when I had lines that were parallel, this F, N, and U sort of shape. So what do I see here? Let me just change colors. Can I see some sort of a N here? Like I can see some sort of a N. So whenever I've got a N, so I'm on this case here. So that means the angle here is equal to this angle right there. So let me just remove it so that we don't make the drawing dirty. So that means D1 equals also 75 degree. Let me just write 75 degree right here. And what is the reason? Alternating angles, right? I drew it for you. What else can we see? What else do we see? So we're asked to find A1. A1 is right here, right? So A1 and this angle here are equal, but we don't have this angle here. They should be actually alternating, but we don't have this angle here, so we shouldn't go that route. What else do we see? We also see something very interesting, is that we see A2. A2 gives us also 30 degree, right? Because we have a, let me just show you here. Can you see I've got a N as well? Remember this line is also parallel to this other line. So I can have a N here, sorry. Let me just draw this N. That means the angle here will be equal to the angle here, right? Let me just delete it again so that we don't overload our drawing. Okay, so if I've got 30 degree here, it means A2 is equal to 30 degree, right? So we also have 30 degree here. It's very important to mark the degree so that it takes shape bit by bit, and it kind of helps as well. Let me just delete this. It's a bit dirty. We can't see what we've got here. This is 75, right? Now, can we now get A1? It becomes easy for us to find angle A1 because now we've got a triangle. So I'm drawing this triangle here, this one. So we know interior angles. Here we know that we've got 75 angle. 75 degree. We know this interior. We know the next interior as well is 48, right? And that's very interesting. Knowing these two interior, what what can he give us as information? We know that the sum of interior angles in a triangle equals what? 180 degree, right? What else do we know? We know that the sum of two interior, we also know that sum of interior angles, is equal to the opposite exterior angle. So that means, what are the opposite of these two interior? It should be somewhere in this vertex. What is the exterior of this? So it means this angle here, that's the exterior angle opposite to these two interior. So if we sum up these two angles, we get the angle here, right? Also, let us remove this. What can we delete this? Okay, what other information do we have? That we can also find the interior angle here. Right here, right? Of this triangle. Because we know that the sum of all interior angles gives us 180 degree. So this is the first statement. Sum of all these three interior angles should give us 180 degree, and then we'll able to find the unknown here. What is this angle? Also, knowing these two angles, we can find the exterior angle. So now let's come back to our drawing and see if we can replicate the knowledge we gained. So let me just try to erase this. What have we got now? It means we can now find y. It's easy for us to find y. Okay. Can we find a1? Yes, we can find a1. a1 we can find using this statement right here, right? The sum of interior angles. So what are we going to have? Well, we are going to say a1 plus 48 plus 75 degree equals what? 180 degree. What are the reasons? The reason is sum of interior angles in a triangle, right? And now we can solve for a1. And now what are we going to get here? So we just solve for this. So we're gonna get a1. So it's 180 minus 48 minus 75. And we just have to take a calculator and we get the answer, right? So why did I take the calculator? Do I still have a calculator here? Okay, let me just see calculator. Okay, let me see calculator. No, it was Casio. Why did I put this calculator there? Okay, so it's fine, no problem. So let's move to the next one. So what about y? So y would be, I think the question, the next answer with y, it's pretty easy with the next statement. We just do exterior, right? Can we see that the sum of these two should be equal to the exterior, and the exterior is y. So basically y is equal to the sum of interior, okay, opposite. It should be equal to 48 degree plus 75 degree. And what do we get? So basically, it's going to be, okay, it's going to be 83. So it's going to be 123 degree. Looks like it's going to be 123 degree. And here in this case, the first answer, this was supposed to be, I think, 57 degree. So I hope that my mental calculation is correct, but you can check it with your calculator. Okay. And what is the reason here? So basically, I wasn't supposed to write the answer before the reason. Let's just write first the reason here. The reason, I've wrote the reason here, right? So it's sum of interior angles equals the opposite exterior angle. So that's what happens in a triangle, right? And now we need to find x. Okay. What is x? No, x, we found it already. It was 30 degree, right? X, we found it before. It was 30 degree. The reason was that it was alternating. Remember, we have, this is parallel to this. So we can draw an N, right? We can draw an N with this. Okay, let me just see. This is parallel to this one. And this side is parallel to the other pair, which is opposite. So x was 30 degree. The reason, we had alternating angle. Okay, great. So we're done with that. It was pretty straightforward, very easy. Okay, what about 4.5? Right. Let's see what we've got. What is what do they want us to do? This calculate with reasons the size of PRS. Okay, so they want us to calculate this size, this angle, PRS. But they say R1 plus R2. So what they mean is they don't want to find the inside, not the inside, but rather they want us to find this one outside, you know, the reflex side of it. Okay, I think that's pretty forward. Okay, basically, what can I say? Like, if we have, suppose you have this angle right here, and then you know that the angle right here is 130 degree. How would you find the one outside here, right? Just an example. So we know that, and what would be the reason? So, okay, let's say you have to find, this is x. So x will be what? X will be 360 degree minus 130 degree. Because we know that the total angles around the point. So the total angles around the point is always 360 degree. Right? So we say angles, we can say angles around the point like this. Is 360 degree. So that will be the reason we can actually use. And now, when we do the subtraction, so we get 230 degree. That will be the result of x. So this is just an example for you to understand what's going on here. But this is not the case. This is not what we're solving for. It's just some quick revision. Great. Now let's solve for this. Let me also clear this drawing so we know what we're looking for. Great. Now, what do we know? Okay, I think all the angles are marked there. We know that we need to find the angle outside. as again, whenever we solve, we need to, go step by step, find the little angles that we know. Right? I think what we need to find is to find A in this case. We'll have to know this angle. It's going to help us to know the other one outside. But how do we find A? Well, can we see that this line is parallel to this? What does it mean? It means that we go back to the same situation with the U, right? So that means we can have a U here. So this forms a U. Whenever we got a U like this, we must know we got a case of co-interior angles. So we can call this one T1. So we can name this one. What does it mean? It means, if we don't want to name that one, we can also say it depends. Let me just delete this. We can also recognize that we have a Z or N, right? If we have a Z or if N, it means if we have 58 degrees there, here it's also 58 degrees, right? And with that, we would now have 3 angles on the straight line. That means 58, that means 80, and T1. So basically T1 plus 80 degree plus 58 degree should give us 180 degree, and the reason is the sum of angles on straight line. Right? And now with that we can find T1. I'm sure we can do that. So all we need is a calculator. So T1 will be, so we bring all this on the other side, on the right hand side. So we already had 180 degree on the right hand side, and all these terms minus 80 minus 58. Now T1 would be equal to what? So 180 minus 80 is 100, minus 58 is going to be 42 degrees, right? So now we've got T1, which is 42 degrees. So now we found this to be 42 degrees. Remember, we need to find A. So now it becomes even more simple because we have a triangle, right? This triangle here, sorry. And we know all interior angles except one, except the A. So we can find A basically. So we say A plus 22 degrees plus 42 degrees equals what? 180 degrees. What would be the reason? So the sum of all interior angles in a triangle, they all sum up to 180 degrees. So what do we get here? So we get A equals 180 degrees minus 22 minus 42 degrees. What do we get here? So this would be minus, this will sum up to minus 64. And what do we get? So we get 116 degrees. So A will be 116 degrees. And remember, A is the interior side, right? 116 degrees. But what we asked to find is these angles outside. Let me just use this green again. So we're asked to find the angles outside. So we can call those one denoted by R1 plus R2. That's the one they want us to find. So it means those angles outside will be equal to 360 degrees minus A. The A we just found, minus 116 degrees. The reason will be, the reason I think I gave it right there, here. Let's see if it's still up, but it doesn't matter. Looks like I've deleted it. So it's angles around, angles around the point, right? Angles around the point. So the total angles around the point should sum up to 360 degrees. Suppose you have this point and then you have different angles like this. Okay, just an example. You have this is point A. So this point A divide the space in 3. 1, 2, 3. Okay. So basically, all we know is that A1 plus A2 plus A3 should be equal to 360 degrees, because the sum of all angles around the point gives you 360 degrees. So the same logic applies here as well. If we want, we can do it from the first step. We can say, okay, the angle we're trying to find here plus A equals 360 degrees. Okay, or 116. And the reasons is angles around the line, right? Around the point. Can be specifics, angles around a point. So the total sum of all angles around the point should give 360 degrees. And now, so we'll have R1 plus R2 will be equal, so we move this term that side, so it's going to be 360 degrees minus 116. Okay, so this, again, we use the calculator, which are omitted. So we're going to have 244 degrees. I'm sure that will be the correct answer. So do 244. So if they wanted R1 and R2, so R1 exactly, because it's equal to R2, will be half of that. So will be 244 divided by 2, which is this would be 112. So 122 degrees. How do I know they're equal? Is because of this point. Can you see this point? This point here, they put 1 point and 1 point there to say exactly that the value of this angle is the same with this value. Otherwise, they would have put maybe 1 point and a cross there, or 1 point and double point this side to differentiate both. But since they're equal, it means R1 and R2 have got the exact same value. So that is all for us. I hope that the solution will be very instructive and going to help you practice mathematics. Thank you very much, and please subscribe.